Hello, this is Algebra 2, Topic 8-6. These are the notes for Topic 8-6, and this is a review of rational expressions and equations. Now, this is not what the rest of the unit has been about, but this is what the previous unit, Unit 7, was about, and they do show up on the test, and this is just a refresher because they're more complicated problems, and we want to make sure that you know how to do them before they pop up on the test. So, the general idea when you're simplifying rational expressions is that you want to take it step by step, making it as simple as possible each go round. Well, the very first thing we're going to do is we're going to go ahead and start factoring some of what we have, because we can't simplify things until we've got it factored. So let's go ahead and start over here. I want something that will multiply to a negative 14 and add to negative 5. Well, that would be a negative 7 and a positive 2. If we come over here, we want something that will multiply to negative 6 and add to negative 1. Well, that would be 3 and 2, with the 3 being negative. And now we want to multiply to a positive 21, adding to a negative 10. Well, this would be 7 and 3, but since we're adding to a negative 10, we need to make these both negative. And this one is as factored as it's going to get. So let's go ahead and rewrite these. X plus 2 over x minus 7, x plus 2. Divided by, let's go ahead and take a look at this. This would be x minus 3 and x plus 2 all over x minus 3, x minus 7. Well, before I go any further, I would notice right now that I've got some similar terms. These x minus 3s are similar, and these x plus 2s are similar. So I can go ahead and just eliminate those. And now we're going to look at it, and we notice again that this is divide. Well, the simple statement that I teach my junior high students, when dividing fractions, don't ask why. Flip the second one over and multiply. Works very well for us. So the first one remains the same. And the second one, well, the x minus 7 goes on top, and the x plus 2 now goes on bottom. Now, multiplying fractions is real simple. You just connect the bar and treat them as if they're the same fraction. Now you'll notice we have another pair. These x minus 7s are the same, so they'll cross out, leaving us just with 1 over x. Sorry, this should be a plus 2. So, we just do it one step at a time, slow steps. If you have no idea where to go, go ahead and begin by factoring, and then looking for similar things that you can cross off. So let's go ahead and take a look at example number 2. Alright, well, let's go ahead and let's factor. This top one will factor to x times x minus 1, because I can pull an x out of both of those. On the bottom, I want something that will multiply to negative 10, add to 9. Well, that would be negative, so that would be a positive 10 and a negative 1. So x plus 10, x minus 1 minus 3 over x plus 10. Well, I've done the factoring, and you can right away notice some similar terms. We cross those off. So now we have x over x plus 10 minus 3 over x plus 10. Well, this made things very nice for us because we have the same denominator. That means we don't need to do any multiplying. Everything's just going to stay where it is, and in fact, we can just put it together. X minus 3 over x plus 10. I look to see if there's any way that I can factor these. I can't. They're not the same, so they don't cross off. This is, in fact, our answer. Again, take it one step at a time. Begin by factoring. Let's go ahead and take a look at number 3. Well, number 3 looks fairly complicated. We've got fractions within fractions. And that's confusing, so let's see if we can come up with a way to get rid of these fractions. Well, I'm looking, and my fractions within fractions happens to be this x minus 2. In fact, that is our least common denominator, is x minus 2. So let's go ahead and let's just multiply this whole thing by x minus 2 over x minus 2. That's just a fancy way of saying I'm multiplying by 1, but I'm multiplying by the one that I want. So we do this. We do x minus 2 times 2x. And for right now, let's just leave it like this. Because remember, keeping things factored usually helps us. Plus, now if I multiply all of this times x minus 2, the x minus 2's will cancel out, so I just get x. And these terms are added. Do the same on the bottom. Well, 2x times x minus 2. Again, we're going to leave these factored for now. This time it's a minus, and this time it is x. Now I know right now you're tempted to go, well, the 2x and the x minus 2, we can get rid of those. Unfortunately, we can't, because since we have the plus and the minus, that means that this is not a single term, and I can only start crossing stuff off if it's a single term on top and a single term on bottom, or it's just terms that are multiplied. Adding, subtracting outside of these parentheses, that doesn't cut it for us. So we are going to go ahead and have to distribute and then start combining terms. So here we get 2x squared minus 4x plus x. We get that on the top. On the bottom, it's almost the same thing, but instead of plus x, we're talking minus x. Well, I've got some similar terms, so this will just become 2x squared minus 3x over 2x squared minus 5x. And I factor, and I can pull an x out of both of those, so I get x times x minus 3 over x times x minus 5. The two x's get rid of, leaving us with just x minus 3 over x minus 5. So, factoring is good, but sometimes we do have to combine terms and get a large statement and then factor again. So don't be afraid to go ahead and start multiplying. You may need to factor, you may need to combine. Just whatever you do, whatever steps you have to take to slowly make it more and more simple. Let's go ahead and move on to example number 4. This is a little bit different in that we have an equation. So I'm looking at my equation and I see some fractions. Fractions make things difficult. Let's see what we can do to get rid of the fractions. Well, to get rid of fractions, you can simply multiply by your least common denominator, like we did in example number 3. So let's figure out what we have. Well, this will multiply into x plus 2, x minus 2. So I need everything to simplify to be x plus 2, x minus 2. Well, if we look at my first term, if I multiply it by x minus 2 over x minus 2, That's just multiplying by 1. Multiplying by 1 doesn't change anything, but it does give us something more to work with. That gives us 2x times x minus 2 over x minus 2, x plus 2 equals 1 over, we're just going to go ahead and keep this stuff factored, plus, and this one, I need to turn that 1 into something I can use. So if I multiply it by x plus 2, x minus 2, over x plus 2, x minus 2, I'm really just multiplying by a very complicated version of the number 1. And 1 times 1 is 1. So we can go ahead and just rewrite this as x plus 2, x minus 2, all over x plus 2, x minus 2. Now again, you're going, well, we have some similar terms that we can cross off, but we just added these terms on here, so we don't want to get rid of them just yet. We added them on here, for a reason. Let's see what that reason is. Well, that reason was because now our denominators are all the same. And because our denominators are all the same, I can cross them all off, because if I just multiply everything times x plus 2, x minus 2, it'll cross off, leaving us with just the top. 2x times x minus 2 equals 1 plus x minus 2 x plus 2. And I may have rearranged some of these numbers up top. It really doesn't matter. Well, now we've got some crazy things going on. Let's go ahead and multiply this out, distribute things out, and let's see what we get when we do that. Well, we have 2x squared minus 4x equals 1 plus x squared. This would be a negative 2x plus 2x goes away, and negative 2 times 2 makes minus 4. Combine some like terms. 2x squared minus 4x equals x squared minus 3. And here we have a quadratic function. And I want to solve for x, which means I need to get everything to one side so that I can either factor or use the quadratic formula. So we're going to minus x squared and add 3 to both sides, giving us 1x squared, because 2x squared minus 1x squared is x squared, minus 4x plus 3 equals 0. Now we can go ahead and factor this into a pair of things that equal to 0. I need to add to 3, multiply to negative 4. That would be 3 and 1, both negative. So minus 3, minus 1. Set each of these equal to 0. X minus 3 equals 0. X minus 1 equals 0. Add 3 and I get that x equals 3. Add 1 and I get that x equals 1. So I've got that x equals 3 and x equals 1. And you'd think we'd be done, but maybe not. The reason is I've taken something very complicated and I've boiled it down to something very simple. When you do that, there are some numbers that simply make this equation explode. The reason is that we can't divide by 0. So if plugging any of these numbers in changes this to be something divided by 0, then that number doesn't work. The graph simply doesn't exist at those points. We have asymptotes or holes. So let's take a look. Let's see, well, 3 plus 2, that's not 0. I don't even need to figure out what it is. It's 5. But I should know 3 plus 2 is not 0. 3 squared is 9 minus 4, also not 0. So we're good with the 3. Let's try the 1. 1 plus 2 is 3, not 0. 1 squared is 1 minus 4, also not 0. So neither of these turned out to be 0, which means that none of them are a whole or asymptote that we have to worry about. So that means that x equals both 3 and 1. And so that's our answer for number 4. Now, if you have any questions, please ask me in class. Feel free to rewatch this video if you need to. Again, this was not covered in the previous topics for this unit, but it was listed in the previous unit, and they will be on the test, so I wanted to make sure that you knew them before they came back up. Good luck on the assignment, and have a good day.